Hello friends, today we'll be studying about a software called DSch, which is mainly used to design the logical gates and also to analyze different kinds of digital electronic circuits and also analog electronic circuits. First, I'll try to give an overview of this particular software and we'll try to design one transistor diagram, or we'll try to see how one logic's gate will be working. So first, this particular software has got these options like you can find in the file. There are some options like new, open, save as, foundry, where you can select the different kinds of foundries of different nanometer technology or micrometer technology. And we can even, with the help of this one, we can even make a Verilog file of this particular design, and we can use it in the another software to extract the layout of that particular design. And again, we can see the schematic or schema of a new symbol, schema to the new symbol. The whatever the schematic you work it out over here, we can make it as a symbol here. And different kinds of properties are there where you can see the main properties like different symbols of how they are being used and how to extract. Click here to extract and extract updated. So different kinds of things are here, and miscellaneous you can see. You can make a changes to this one whatever you want as per your design. So after that, again, you can see monochrome. We can make it as a monochrome, where you can see it as a monochrome. This is a monochrome background, but I'll use it as a color one. Why? Because it looks good while making the connections. And that is that one. And next, in edit, you can see these are the options where we can use undo, cut, paste, copy. This is the normal. And again, rotate left, rotate right, flip. We can use a flip for the transistors in order to change the its particular position horizontally or vertically, and line where we can use it as a connection and contact, and text has been used in order to make the naming of that particular circuit. We'll see while making this one. Then again, insert, we can use a symbol. If you have got designed earlier any symbol, we have seen here make a schema of new symbol. This symbol can also be inserted, and we can use that one wherever we want in the in our designs. View, you can see here a zoom in, zoom out, and again electrical net timing diagrams by which we can abstract or extract our outputs. This symbol library, if you click this one, this is a palette which you find it out, which has got different options again in it. And after that, we'll come to that palette later, and then simulate we can simulate that one by using the simulate button, or the shortcut key is F2. And again, help, you can see the manuals of this particular software. Now coming to this one, see here all the shortcuts have been given here: open file, save file. This is the, you can see different kinds of symbols where schema to the symbol creation window will be opened. And again, this is a cursor and cut symbol. This is a cut. Gun option is a cut. Again, copy. And this one you can see here, move shortcut. This is a rotate one, rotate to left, rotate to right. This is a flip to flip one, flip vertically and flip horizontally. And this is a text. So if you want to write down, if you design any of the AND gate, you can name it that one below that particular AND gate. Then again, this is a add a line and connector contact is that simulator. In order to run the simulation, we use this one, timing diagram. All we can, once if you have designed, if your circuit is very large and very big, if you want to see all the circuit in one look, you can use this one, all. If you click this one, entire circuit will be visible over here. There's a zoom in, zoom out, and these are the electrical net option. This is for the symbol library. That's a palette. You can see here now in the palette there are two kinds of options. First one is advanced one and basic one. First we'll try to see the basic. In the basic, you can see these are the different options which have been given over here. First one is it's a button is nothing else but which is used as an triggering of input trigger. Then after that is the next one is a ground, then power supply. This is for the clock one, and this is a light. Light is nothing else but it's used in order to obtain the output. The next one is a hexadecimal input where we can give it, and this is a inverter in the form of logic. It's a logic inverter. This is a buffer, 3-state inverter, and next one is a buffer, and this is a two input AND gate, 3 input AND gate. Then next you can find the keyboard of a hexa keyboard. This is a NAND gate, 2 input NAND gate, 3 input NAND gate, and this is a OR gate, 2 input OR gate. This again, next one you can see that now you can see here now. This is a OR gate. It's a OR gate, and this is a NOR gate, two input NOR gate, and this is a three input NOR gate, and this is a three input OR gate. And here you can find here XOR gate, two input XOR gate, and two input XNOR gate. And this is a fall edge sensitive D register. It's a D register, and after that is a two inverters transistors. Sorry, these are two transistors. This is a NMOS transistor, and this one is a PMOS transistor. And after that we will see the level sensitive latch is given, and here is a three input complex gate, where you can see that AND gate is been uh, driving has an input to the OR gate, and again here is a 5 input complex gate, again AND and OR has been used over here, and there's a mux 8 cross 8 mux is there. So this is a palette symbols which can be used in order to make the diagram or the schematic of structure which are present in the basic one. When you go to the advanced, in the advanced you can see electrical resistance has been given, capacitance is given, inductor, and after that you can see here op amp is given. After op amps, diode, then transmission line. Coming to the sources, you can see piecewise linear source is there, current source is there, again voltage source. Coming to the displays and outputs, it's an 8-bit display. After that, input and output pad, and on and off switch is given, and different kinds of switches are given here. You can see different kinds of switches like programmable interconnect point and programmable switching matrix switch is given, and after that multiplexer, different kinds of you can see this one is a lookup table, three input lookup table, and on and off switch, and this is a transmission gate. And miscellaneous, there are some miscellaneous like box, arrow for the electrical connection, and this is for the information probe, and this one is a microcontroller 8051 microcontroller, and also 16F84 microcontroller. Two different microcontrollers have been given. So this is regarding the overview of this particular software. And this one in the background here, if you want to design a small CMOS inverter, let me try to design a CMOS inverter and tell you how it works really. So first I'll go to the basic. Why? Because in the basic library only we have got the inverters. We have got the transistors. So first, in order to design a CMOS inverter, we need a PMOS and also NMOS. So first I'll take a PMOS, and first you click on this one and drag it. Click it and drag it, you get the PMOS over here. And after that, you can again click on this one, click on the NMOS, N channel MOSFET, and drag it over here. Now we have got the NMOS. So once if you drag this particular transistors from the palette onto this particular software, now you can use a line connection line, add a line. You can see an option over here, it's a add a line, this one, and click over here on the drain of the PMOS and drag it. And in the same way, for the CMOS connection, we know that inverter connection, both the drains of the transistors are to be connected, and also gates of the transistors are to be connected. So this is a gate of the PMOS. Gate of PMOS is to be connected to the gate of a PMOS is to be connected to the gate of an NMOS. And now if you want to come out of this one, escape, put escape button. If you want to see the source terminal and all these things, you can see here now. See now, when you double click this one, if you double click this one, you can find different kinds of one window is open, where you can see that the symbol is what PMOS, and its properties have been given here. The width of this particular transistor has been given, channel length is given, and again what kind of MOS model it is, a MOSFET PMOS type of model. So it's a PMOS model, and here you can see generic name is PMOS and user title is PMOS. What are the name I have given? It's only PMOS. Position and its where it has been placed in that particular software, and the pins have been mentioned over here. Source, S stands for source, G stands for gate, and D stands for the drain terminals. So now here this is a delay, fan out, and the loads have been given. You can even use these options where it shows the pin names. If you click the pin names, you see here now, if I click the pin names and click OK, you can see here now all the names of this transistor has been obtained here: source, gate, and drain terminal. In the same fashion, if I click on this one, pin name of the NMOS, I can obtain the gate, source and drain of the NMOS. Now let me make the connections. First I'll select the supply VDD from here, and I'll connect it to the source of a PMOS, and also I'll select a ground terminal for this one. This is a ground terminal, you can see here now, and I'll drag it and I'll connect it to the source of a NMOS. If I connect it like this, you can see now the connection has been done, but I need to make a connection for the input and output. For that one, I'll use a line, add line, select it, and then click it on that place wherever you want to make that add line. Click it here and use a left click on the mouse and drag it. And in a similar fashion, I need a output over here at the shorted gate terminal of both the transistors, and click it over there and left click of the mouse and drag it. So see now we have made the connection. Now after that, I need to give an input. So here input, what I'll try to do is that I'll take the input from the button. Why? Because I want to show you how the PMOS is going to work here. So I'll click on the button and I'll take it as an input. You can take it as a button as an input, or else you can even use the clock. But when you use the clock, it will be a very fast operation of the both PMOS and NMOS. But when I use the button, I can show you how the PMOS is working and how the NMOS is working in the simulation part. Now for the output, in order to obtain the output, I'll use an option called this one, light. This is used for in order to show the output. This is a symbol out1. So see now this is the output, out and out1. So now if I want to make an label of this one, I'll click on this A. Here I can give it as CMOS inverter. You can see CMOS inverter. Now I have placed it. You can place it anywhere. CMOS inverter. This one you can drag it and you can place it anywhere. Now I have put the name of this particular circuit diagram. Now once you save it, save for the saving one. I'll save as, give the name of this one. I'll save it as a CMOS inverter. Why I could put that this hyphen? Because it might be same name in the other software I want to extract the layout. So for that one I have put the hyphen. I'm trying to save it on the desktop. Why? Because it will be easy for me to call that one file into the another software. So save it. After saving that one, after saving this particular software, you can click it as run simulation. This is a run simulation. Run simulation. You can see now whenever this particular input is 0, we have not triggered any input. If input is 0, what happens here? We know that when the input is 0, the PMOS is turned on, you get the output high voltage as an output. That's a voltage flows because a channel has been created and voltage flows to the this one. So anyway, it will be like VDD minus VT will be the output at this part. And if I try to give an input as an logic 1, we can see the channel is open for the PMOS and the channel is closed for the NMOS. So in this case, what happens? Whatever the output has stored over here, it gets discharged to the ground terminal through the capacitances at this output. So this is now what's happening. Whenever the input is logic 1, output will be 0. If input is equal to 0, then the PMOS is turned on and output will be 1. So this is a normal general working condition of an CMOS inverter. It's nothing else, but it's a NOT gate. So you can, I'm trying to trigger it so that you can find the different kinds of timing diagrams here for different initiations of the pulses. So see now, once I have triggered this one, you can see here for one instance the channel of the NMOS is turned on, and for the other one channel of the PMOS is turned on. It means what? At only one time, at one instance, one transistor will be turned off and other transistor will be turned on. Whenever the PMOS is turned on, what happens? You get some output at the high voltage as an output. Whenever the NMOS is turned on, you get a low voltage as an output. So see now, for this one we'll try to extract the timing diagrams. So this is the timing diagram window. You can see here now input is this one. Whenever the input blue here, it is low. Whenever the input is low, you can see here low, blue line indicates low input and red line indicates high one. So low is a low voltage is indicated by blue and red is indicates a high voltage. So whenever the input is low, the output is going to be high. Whenever input is high, output is going to be low. So this is how the CMOS inverter will be working. So this is regarding a particular software called DSch and how to work on this particular software. Now we have completed the working of this particular CMOS inverter, and we have seen the characteristics of the CMOS inverter here in this particular software. Now we'll try to go to the another software which is called as Microwind. So this is a Microwind second version, which is this both the softwares are freely available in Google or search engines. You can get it from there, or from the Microwind website also you can download easily, freely available. So now here, if I want to take if I want to create the layout of that particular software, sorry, if I want to create the layout of that particular design which I have designed over here in this particular DSch. So what I need to do is that I need to first, after saving this one, I need to go to file, make a Verilog file. I need to make it as a Verilog file. Make a Verilog file. It's a MOS inverter module Verilog file. OK. Click OK. Click it OK. And let me see where it has got saved. Verilog file, and click it OK. Now I'll try to go to the MOSFET Microwind software. In this one, I'll file. I'll try to compile 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 option. Compile Verilog. I have clicked on compile Verilog. Then we'll try to go to desktop. In the desktop, I'll try to see whether that file, Verilog text file, it is not created in the desktop. So now I'll go back to the same file wherever it is there. I'll look for that particular file wherever we have saved it. So you can see here inverter CMOS. So now I have selected from this DSch file, or else inverter CMOS. Open this one. Once after opening that one, inverter CMOS, whatever you have selected, uh, enlarge this one and compile. Click on compile once. This on the Verilog file. You can see now in this particular window, you can see the Verilog code of this particular inverter which you have designed. Module inverter CMOS in is a input and output, both the inputs. Then again input IN1, output out1. Then again we are declaring the NMOS and its details, and again PMOS and its details. So end model. So this is a Verilog code for the CMOS inverter. For that one, click compile, and after that back to the editor. You can see this is the inverter layout, CMOS inverter layout, which has been extracted from the DSch software, where we have created a make it as a Verilog file. From that Verilog file, we have created this layout. Now we'll try to see whether it's working correctly or not, whether it's extracting the same outputs or not. First, save it and run the simulation in the Microwind. You can see now. This is it has got some errors. Why? Because we have not designed this layout as per the rules. It is automatically generated, so it has got some glitches. You can see some glitches are over here. Once if you try to sort it out manually, all those errors wherever that glitches have been occurred, and if you try to design this one as per the rules and regulations of the layout, then we'll be getting the exact outputs. See now, everywhere we are finding the same glitches. So now this is what we get. Whenever the input is low, you get a high output. When input is high, we get the low output. So this is how this particular two softwares will be working. In one software, we'll be designing our complete design. Once if you can design the schematic part, after that you will be making up the Verilog code, and we'll be using that Verilog code, or we'll be calling that Verilog code into a new software called as Microwind, where you can design the layout of that particular software. So this is two softwares are interlinked, where we can use it combinedly for making the projects in our BTech or MTech courses. And we can even it's very easy to learn the designing part of a layouts. This particular Microwind software is very easy, where it has got a palette also here. If you click on this one, you get a palette where your different kinds of metal layers are there. In the previous video, in the video called as a CMOS inverter layout design, which I have made, you can go back to that particular video and you can look at how to design a layout of an CMOS inverter using a Microwind for the VLSI lab. So I would design that one there. You can design it manually also, or else if you are facing any problem in designing it manually, you can use these two softwares in order to extract the layout of any of the structures or schematic diagrams which you have designed in the particular previous software. So this is how these two softwares will be working. I hope everyone you have understood this particular softwares, and I think that this particular lecture is very clear to you. If you have got any doubts regarding this one, you can post your comments in the box below, and you can come back to me. I'll come back to you by replying your all the comments. Thank you, everyone.